Hi, welcome back to the Learn with SLIIT FOSS video series on computer networks module, and I am Laksiru Semasinghe from SLIIT FOSS community. This is the second video of this video series, and in this video I'll be discussing about the basics of networking and networking terminology. So let's move on. So this is the content I will be discussing in this video, and I will be going through network topologies, and we'll compare and contrast collision domains and broadcast domains. Then we'll be comparing hubs, switches and routers, and then we'll be talking about the connections, straight through, crossover and serial connections. Then we'll be talking about this networking model called ISO model, sorry. And at last we will be talking about IP addresses and MAC addresses. In this video I won't be going deeper with these topics. I will be just touching these topics just enough to go to the other videos in this series. So let's move to the first topic. So these are the network topology types. So network topology is the logical arrangement of network devices in a network. So here we have 7 network topologies, but most times we don't see one of these type of network topology in a network. Like most of the times we see a hybrid network, which includes multiple types of network topologies like point-to-point, star and bus. So in a usual simple network, what we see is a star topology. So even in like if you, as an example, if you take a SLIIT lab, there we can see a hybrid topology of a star and a point-to-point. So something like that. So like it's like if you are connecting multiple computers to a switch, and such a network will be in star topology. So in SLIIT labs we usually see multiple, there are like 30 to 60 computers. So like these computers are connected to most probably like 2 switches. So like 24 computers connecting to one switch and another 24 computers connecting to another switch, something like that. So and so like this is one switch and this is another switch, and computers connect to this switch like this. So this is one star topology, and for this switch also there are computers connected to it. So this is another star topology. So independently these are star topologies, but when we connect these 2 switches together, this will be a point-to-point connection. If you just take only the 2 switches like this, and this will be a point-to-point connection. So that's what include here. So when taking the whole thing together, it will be a hybrid topology of star and point-to-point. So if you take a simple network with the hub in middle, so like just this is the hub, these are switches. Okay, if you take a hub and there are computers connected to the hub, even if it looks like a star, this will be an bus topology, because in hub, in later of this video I will explain this much deeper. So here the hub is a dumb device. Like what it does is it connects to all these all connections to one single medium. So if this computer sends a signal to this cable, it will be available on both these cables. So if this computer sends something, both of these computers will get. So it's like a single medium, like the whole this thing is a single medium. So it's like this, all these are connected to, if I simplify this, it's like 3 computers connected to the same medium like this. The hub will be like a single medium, so it will be a bus topology. We don't usually see other types of devices now, like this ring topology is rarely seen these days in modern networks. So let's move to this slide is about collision domains versus broadcast domain. So first of all, let's see what is a collision domain and what is a broadcast domain. As I told earlier in the week's video, if you are using a hub, all the devices connected to the hub will be connected to a very single medium like this. So it's like a bus topology. So if this guy sends something to the medium, like this guy wants to transfer something, it will be available on throughout the medium. So these guys also can listen to it, like they can get the message. So it's like it will be unnecessarily available on throughout the network. If this is the network, it will be available throughout the network unnecessarily. So this will be a problem when we are connecting multiple devices to the same network. If it's on this kind of single medium, like if you think like this, if there are 4 computers like this, let's see, this is A, this is B, this is C, and this is D. So just think these are connected like this. So all are if I draw it like that, it's just something like this. We have ABCD. So if someone wants to, just think, I'll also explain it to this video also. If A wants to send something to C, this is A, B, C, D. A wants to send something to C, even B and D will get the same data because all of the 4 devices are connected to the same network. So in the same time, if B wants to send something to D, it's not possible because A and C are using the medium for their communication. So because of that, if B wants to send something to D or something like that, or vice versa, there will be a collision on the medium, like A's messages and B's messages will be collided with each other. So this will be happen throughout this medium. Like if A wants to send something to B and if C wants to send something to B, same will happen because A's message will be available throughout this medium until here. And if D wants to send something to B, D's message will available throughout the medium until here. So even if A wants to send something to B and C wants to send something to D, it's not possible at the same time because the whole medium will be allocated to that message because the medium is not divided into parts. So this causes collision of the messages. So each other has to avoid collisions of the messages, and it is a resource stage, some kind of. So to address this problem, we break this. So if we take this whole medium as a whole network as a domain, we divide this domain into further parts. So we call it a collision domain. To divide this medium, we use a switch. So by using a switch, it divides this domain into parts like this. So we can't do it on a bus topology. We have to use a star topology for that. So if we are applying a switch here, just think this is a switch. This is a switch. So when we are applying a switch here, what it does is it divides these networks into 4 collision domains. Like for each port of the switch, there will be a separate collision domain. So when A wants to send something to B, what the switch does is, when it gets the message from this port and check whether to which device it should be transferred, and it transfers that to that device. So just think, if A wants to send something to B, it switch gets the message and transfer it to B. So it won't go to these 2 networks, these 2 collision domains. Like as I told earlier, switch divides these into collision domains. So this is one collision domain. So as I told earlier, switch divides the networks into collision domains. So this will be one collision domain, and this will be another collision domain, this will be another collision domain, and this will be another collision domain. So the collisions will happen only within here. So as there is only one device here, there will be there are only 2 devices, like switch also has a part of here. So there are only 2 devices, there won't be any collisions, because to happen a collision there should be multiple devices, like more than 2. So here also there are only 2, switch and this device, so there won't be collision. So in that way we can minimize the collisions. Actually there won't be collisions if we have programmed correctly. So because of that there won't be collision. So we call this kind of domain, this kind of part of the network, we call it as a domain, as a collision domain. So there will be 4 collision domains. So that's what a collision domain does. It minimizes the collisions. Okay, now let's see what is broadcast domain. So as a defined area within the collision domain, it is also a portion of the network. So according to the definition of Google, broadcast domain is the area of network where a node can access other nodes through just a broadcast message. So broadcast message is a message which is sent, is specified to a special IP address. So all other nodes on the network can receive it. So if you think this is a broadcast domain, if this PC sends a message to the broadcast address, all these 4 PCs will get that message, but not any PC on this area. So because this is a separate broadcast domain. So basically a broadcast domain is equivalent to a subnet. So if you divide a network into further networks, what we do is subnetting. So each subnet will be equivalent to a broadcast domain. So we divide the network into subnets by dividing it into separate broadcast networks. So to talk between broadcast networks, we will need a router, or we can connect 2 broadcast networks using a bridge. So each broadcast network will have a network address, just like, because it is equivalent to a subnet. So let's go to the next slide. In this slide I have compared hub with switch and router. So hub is basically a dumb device, so it can't do any processing. What it does is it broadcasts all the messages it gets via like it just broadcasts messages it gets. So it works as a broadcasting device without any processing. So like if I, as an example, I'll take these 4 devices and I connect it using a hub. So what hub does is, when hub receives a message from this computer, hub broadcasts it into all these computers. So the whole network is still at a single collision domain and a single broadcast domain. So the hub is only used to connect multiple devices into a same single medium. So hub just broadcasts all this traffic into other networks without any processing. So however, because this is just shares the medium, so it do this broadcast as bits, like as this, just think this is a network done by Ethernet cables, so its Ethernet cables are the medium. So what computers does is send electric pulses to this medium. So this electric pulse will known this electric pulses as bits, because these their transformations are done as bits in these networks. So bits are the basic unit in data transfer. So what does switch do? Like what switch does is it just broadcasts this bit by bit. So the data will go, like if one of these devices send the pulse to the medium, the switch just broadcasts it as it is. So as I told earlier in the content page, there is a network model known as ISO model. So there are 7 layers in that model. So this hub is situated in the physical layer. I'll explain these things in that content page, that ISO model page. And let's see what is switch. So switch is used to divide the collision domains. So if we take this as a switch here, so when this computer sends a message to the medium, the switch gets the message and checks which is the which computer is the destination of that message. So to define the destination, we use MAC address. So we can use IP address and MAC address both. And but as switch is in the data link layer, I'll explain this data link layer later in this presentation. In data link layer, we use MAC address. So once a PC sends a message to the switch, it checks what is the MAC address of the destination and forwards it accordingly. So this switches has a table called MAC address table, and it has, so just think this is A1, no, this is 1, 2, 3, 4. So switch has a table called MAC address table, so it has which port has which MAC address. So yes, this MAC address is something like MAC address is, I'll explain MAC address later in this presentation, but just think MAC address is A. So this computer is A. So when this computer sends a message to this switch, it names, it puts the A in front of 1 in the MAC address table, and if this is B, it puts B in front of 2. So it can identify to which port it should forward according to the MAC address. So this forwarding is done as frames. So earlier in the hub it was done as bits. That means if one computer sends a bit, like it sends a series of bits, so hub will broadcast it bit by bit. But in this switch, it transfers as frames. So frame is a bunch of bits which is collected together, and just think we have like 1 0 1 0 1 1 1 like this. There's a specific size to the frame, so there are that much of bits there, and what the sending computer does is it collects these bits and put into a item called frame, and on that frame it labels which is the source computer and which is the destination computer. So those are addressed to the MAC address. So it has the source MAC address and destination MAC address. What switch does is it gets the frame and checks what is the destination MAC address, and checks the MAC address table and get what port it should be transferred to and translate. That's what switch does. So these MAC address things are happening at their link layer. So this MAC address is, so these switches switches are situated in their link layer. It is the second layer of that ISO assembly. So then next is the router. So what router does is it divides the broadcast domains. So when you want to transfer data between two broadcast domains, you will need a router or a bridge, but we don't use bridges much in these modern day networks. So if you think these are two broadcast networks, we use a router here and to connect these two. So when someone sends a message to this network, it just first it comes to router, and router, like maybe there could be multiple networks connected with the router. Router also does that checking on which is the destination, and it forwards it accordingly. So in here, router does this checks on IP address as switch did it on MAC address. So each network has a network address. It's also an IP address. So, but within that network, the computers has IP addresses under that network address. So when switch gets the router gets an message, it checks to which IP address this is going. So according to that IP address, it has a table which we call it routing table. In routing table, it is like that. So it has, in routing table, it has ports. Just think this is 1 2 3. Ports are named in a different naming convention. Just for an example, I take it as 1 2 3. So it has this like, so 1 2 3, and this has the network addresses of each of the networks on that port. So just think this is network is A, B and C. So this has A, B, C. So when a computer in this network sends a message to a computer in this network, the message first comes to the router, then router checks to which network it is going and forwards it accordingly to that port. So in this these routers are works on network layer. I'll explain this as with other layers on the ISO network model slide. So this in this network layer, all these transferring things are happened using IP addresses. So this for this bundling, in there also the bits are bundled together. So we call such a bundle as a packet. So packet, there are like there's a header like this. So there we have added the IP addresses like source IP address, destination IP address, and some other information regarding the data within the packet, and here are the bits. So basically this I'll explain that further in later part of this presentation. So that network model is like this. It's like a stack, so layer by layer it's stacked upon each other. So the bottommost layer is the physical layer, then next we have data link layer, and then next we have network layer. So actually the these frames are belongs to each of these layers. The data link layer has frame, network layer has packets. I'll explain this stuff later. So in network layer, all these bits are packaged into a packet. We call that bundle as packet, and transferred through the router. So router gets a set of bits bundled as a packet, and on that packet it has a label, so it transfers them accordingly using the information on these routing tables. Okay, now let's go to the next slide. Okay, this slide is about connections. Basically, in these modern day networks, we use three types of connections, but most times what we are using is these two, straight through and crossover. This will be used within a network or within a subnet, we call it. So we use straight through cables to connect different types of devices. So different types means these are the two types. Type 1, we can just, these are two types, just I'll name it as type 1 and type 2. So the type 1 has PCs, routers, servers, and those kind of devices, and type 2 has switches and hubs. So if I want to connect a PC into a switch, that's a connection between the two types. So in that case, because these are two different types, we have to use straight through. If I want to connect a PC into a PC, it's between the type 1. It's within type 1. So it's just within the same type of type. So to connect the same type of devices, we use crossover cables. So the difference between these two cables are the straight through has the same connector, same connecting pattern in the both ends of the Ethernet cable, but crossover cables has two connecting patterns. So you have learned this stuff in ICS in the first year first semester. So I'm just revising this stuff. So other than these two types of connections, we also have a connection called serial connections. So we usually use serial connections for point-to-point connection types. Like we use serial connections for point-to-point. So as you can see, there are two routers, and we use a point-to-point connection to connect them. So for that, we are using a serial connection. So even in serial connections, there are two. In a serial connection, there are two ends. So if I take this is one end and this is the second end. So here you can see a small clock here. So that means this is the DCE, and if that's the DCE, other end is definitely the DTE. So DCE is the data communication equipment, and DTE is the data terminal equipment. So when we are initializing a serial connection, so we have to declare the clock rate. So we are declaring that on the DCE, so it communicates it through the other end and negotiates it. So we also use this serial flag. These serial connections are using the serial ports on those router or whatever device. So when you are configuring a router or switch, your switches has these serial connections, serial ports, we are using this special cable. So in this special cable, one side has a DB9. One side of this cable has a DB9 port, and other side of this cable has a RJ45 port. So we connect this to the device. Device means router or switch, and this to the PC. By doing that, we can make a serial connection to the device and we can control it. So I'll show that with use of packet tracer in a later video. So that's it about these connections. Next, let's see the ISO model. This is the model I told earlier. This is one of the models which is widely used in networking, and we also have another model known as TCP/IP model. TCP/IP model. So it only has 4 layers, but this has 7 layers. So here I'm going to explain about only this ISO model. So the most important point I need to tell you guys is we have to understand the function of these layers, especially these lower layers, from lower layers and the transport layer. We have to understand the features of these layers, and we have to remember the names of all these layers and the order of these layers. So to keep in mind, you have to keep in mind the order in this way as well as this way. So I have mentioned 2 tricks to remember these 2 orders. So if you want to remember the order from bottom to top, you can go with this. Please do not throw SSH keys away. So all these first letters of these words stands for the first letters of these layer names. So if you want to remember the order from top to bottom, you can go with this. All people seems to need data processing. It's same as this one. First letter of each word stands for first letter of each network, each layer name. So let's discuss about the function of this layer. So physical layer is okay. Now let's talk about physical layer. So as I told earlier when I'm discussing the hub, what physical layer does is just what hub does is just sends the medium and just broadcast what it got from the medium to other parts of the medium. So that because of that, the hub works on physical layer. So physical layer is all about medium and signals. So it works with medium and signals only. So when it comes to data link layer is about transmissions from, like, basically node to node communication. If there are just think this is a switch, so there are multiple devices connected. So what switch does is it transfers message from each type. If this guy wants to send message to this guy, what switch does is it gets the message from here and check whether which is the destination and transfers it. So that these are, we call this connected device as nodes. So the data link layer does is node to node communication or node to node based transmissions. So as switch do that thing, switch is considered as a second layer device, but actually switch has both the lower layers, physical as well as data link, because it just data link layer can't exist standalone. So when it comes to network layer is about the communication between broadcast domains. So as I told earlier while explaining the router, we use the router to communicate between broadcast domains. So these within these broadcast domains there are routes. So what router does is it selects the correct route. So network layers function is this routing between the broadcast domains and addressing between these broadcast domains. So within these broadcast domains there are IP addresses. So this whole network layer works on those IP addresses. So this has a network address. Network address is a IP address, and this also has a network address. So according to those network address, network layer works. So the router is considered as a network layer device, but just as switch, it also has all the layers below it. So like this, it has 3 layers: network, data link, and physical. So when it comes to transport layer is known as the socket communication layer. So there what it does is it ensures the delivery of the messages. So each device just take two computers. So these are two computers. Sorry for my drawing. So when we connect these two computers, each computer opens the socket. So like for each application in this computer there's a socket assigned to it. So there are around 65,000 of sockets in each computer. So when one computer connects to another, it opens a socket on each computer. So this transport layer is based on those sockets. So on those sockets, this transport layer ensures delivery of these messages. In later of this video series, I'll be talking about this transport layer and how it works. Now let's move to the next slide. Okay, this is the last slide I think. So here I'll be talking about MAC addresses and IP addresses. So when I was comparing the switch to router, I was talking about this MAC addresses and IP addresses. So we call this MAC addresses as layer 2 addresses because the MAC addresses works as frames. So frames are in layer 2. So we know these MAC addresses as layer 2 addresses, and these IP addresses works on the packets. So packets are on layer 3. So we call this as layer 3 addresses. So we use these MAC addresses to identify devices on local scale. Local scale means within the broadcast domain. So each and every device connected to a network has a MAC address because each and every device needs some kind of network interface card. It could be a Ethernet network interface card or something else. We also use Wi-Fi, which is known as wireless LAN. So there are different kinds of network interface cards. So each of these network interface cards has a MAC address. So it's programmed with using the firmware, so we can't just change it like an IP address. But IP address is not like that; it can be changed. So as it's mentioned on this slide, it can be changed IP addresses, but MAC addresses can't be changed. So a MAC address is something look like this. It has 12 digits divided into parts of 2. So there will be 6 pairs separated by hyphens. So when it comes to IP addresses, there are two types of IP addresses as IP version 4 and IP version 6. Most of the times in our local networks we use IP version 4, but in global networks like internet we use this both. So sometimes if you Google as what is my IP, let me show. What is my IP? Here you can see my IP address here. So it's just, in this case it's a IP version 4 address, but if I go here, here I can get what is the IPv6 address as well as what is IP version 4 address. Here it doesn't detect the IP version 4 address. I don't know what's the reason. When talking about IP addresses, there are two types of IP addresses, so IP version 4 and IP version 6. So most of the times in our local networks like home networks we use IP version 4, but in global networks such as internet we use both IP version 4 and 6. So if I check my current IP address, okay, I have searched for what is my IP on Google, so I have got my IP address. It's a IP version 4 address. So this is the address I have connected to internet. So this is my public IP address. So here it's IP version 4, but sometimes it could be IP version 6 or both. Okay, so IP version 4 has a 32 bit. So we divide it into four parts as 8 bits each. So 8 bits means we can represent up to 256 characters. So it's 0 to 256, 255 because with 0 it's 256 characters. So like this we can have four numbers like this. So as an example, 192 168.1.1. This is the valid IP version for address. When it comes to IP version 6 addresses, there are 1 to 8 bits, so there are like I think billions of addresses, possible addresses there, so it will be look like this. So these addresses, this MAC address is sometimes known as physical address because these addresses are fixed to the device, but these IP addresses are not fixed to the device. It changes from time to time as we allocate them, so we call it as logical addresses. So these addresses are, these MAC addresses are, as I told earlier, these MAC addresses are hard-coded into the manufacturer, the device that manufacturing has. For the network interface card, the manufacturer hard-coded the MAC address under the network interface card manufacturing, but these IP addresses, the network administrator can just assign the IP address as he wants, so we can change it when we want. Like when if it's a mobile device, most of the times we take it from one network to another network. The network, the IP address will changes. If you are using a technology like DHCP, even there the IP address changes frequently. So that's it about this video. Thanks for watching. Let's meet in another video. Have a nice day.